Hello students, let us start with the new chapter, that is mechanical properties of fluids. We have seen the mechanical properties of solids in the previous chapter. We know the mechanical properties means these are the properties exhibited by the substances when a force is applied on it. And we have studied the mechanical properties of solids in the previous chapter. Now we are studying the mechanical properties of fluids in this chapter. And then what is meant by fluids? Fluids, these are the substances which can flow. And we know that only the liquids and the gases can flow. So the liquids and the gases are collectively known as fluids. A liquid has a definite volume. We know that the liquids have the definite volume, but they are not having the definite shape. And when we put some liquid in a container, then that liquid will take the shape of that container. So we can say the liquid has a definite volume but not having the definite shape. So we can say that the liquids are highly incompressible. Incompressible means when we apply certain force on that liquid, the volume of the liquid will not change. That is known as incompressible because the liquids have the definite volume. So when we apply certain force on that liquid, that the liquid's volume will not be changing. That's why the liquids are the incompressible in nature. And in case of gases, gases are highly compressible. When we apply certain force on the gases, then their volume will be changing. That's why the gases are known as the compressible. And gases occupy the any volume. And the study of the fluids at rest is known as hydrostatics or a fluid statics. The study of the fluids when they are at rest, that is known as hydrostatics or a fluid statics. And the study of the fluids in motion. When the fluids are in the motion, the study of the fluids in case of a motion is known as the hydrodynamics. This is the some introduction part about the fluids. Next we have the pressure. Pressure is defined as the magnitude of the force acting perpendicular to the surface of an object per unit surface area of that object. Let us consider one example. Take a needle and put it on your skin. Then it will starts to hurt. Right? We are applying a X amount of force from that needle to your skin, so it starts to hurt. But when we take some other material which is having a broader area, then that time also we are applying the X amount of force only on your skin. That time it will not have that much of hurt, because the greater the cross sectional area, then the lesser will be the impact. That is, if lesser the cross sectional area, greater will be the impact. That is known as pressure. That is the magnitude of a force, means how much extent, that the maximum force we are applying on the object, that too in a perpendicular to the surface of that object per unit surface area of that object, is known as pressure. Consider F amount of pressure force we are applying on a material of a surface area A, that too in a normally. So the pressure acting on that surface is known as P is equal to F divided by A. That is, F is the force whatever we are applying and A is the cross sectional area. This quantity is known as pressure, and we say that the pressure is a scalar quantity because let us consider a container which is containing some liquid, and we have put some metallic block or some object in that liquid. So that metallic object or any object that is having certain faces, on that faces whatever the pressure applied by that liquid will be different at a different directions. So that's why the common direction of the pressure is not there from the liquid. So that's why the pressure is known as a scalar quantity. The pressure in the fluids is not same at all the points. As we have seen, the pressure, whatever the pressure applying on any object is not same at all the points of that object. So if consider delta F is the normal force exerted by the fluid on a small element of area delta A. We have considered a delta A amount of area of any object, and the delta F amount of force is applying on that delta A. Then the pressure at that point is given by P is equal to the limit of delta A tends to 0, delta F divided by delta A. That is written in the form dF by dA. This is the pressure applying on a small area delta A. And in CGS system, the unit of the pressure is dyne per centimeter square, and in SI unit the pressure unit is Newton per meter square, or we can write it as Pascal also. And the dimensional formula for the pressure is M L minus 1 T minus 2. This is about the pressure. Now we see the how we are determining the pressure. Consider a evacuated chamber or a evacuated cylinder. It is a simple device used to measure the pressure in the fluids. So it consists of a evacuated cylinder and a piston. This length is known as piston. That is, piston means it is a disc which can move when a force is applied on it. And this piston is having a cross sectional area of A, and this is fitted into a cylinder. This is fitted in this evacuated cylinder here, and a spring is also connected here, that is connected in between the piston and the bottom of the cylinder. In between these two, a spring is connected. When this device is submerged in a fluid, when we put this device in the fluid, then the fluid starts to enter in this. So when the fluid applies certain force, in the downward direction to this piston. So as a result, the piston starts to move downward. As the piston starts to move downward direction, so as the piston starts to move downward direction, the spring starts to exert a restoring force. We know about the restoring force. So when piston moves downward because of the force of the fluid, when it moves downward, this spring starts to exert some opposite force, that is in the upward direction. Then because of this restoring force, or the force exerted by this spring in an opposite direction, by using this known value, we will get to know the how much force or how much pressure is applied by that fluid on the piston. That is, pressure in the fluid can be determined by using the relation Fp is equal to F divided by A, where we know the cross sectional area and we know the F value. That is, F means by using the force exerted by the spring. Then by using this relation, we will get to know the pressure exerted by the fluid. This is the simple device which is used for the determination of a pressure of any fluid. Next we have a Pascal's law. This Pascal's law means, it has a statement as, it states that an external pressure applied to any part of an enclosed container of a fluid at rest is transmitted undiminished or without loss to every portion of the fluid and the walls of the vessel or the container. As it states that, the Pascal law says that when we considered a enclosed container of a fluid, let us say take this fluid, this container is containing the fluid, and when we apply certain force or a certain external pressure at any point on that container, then that whatever the external pressure we have applied, that will transmit through the every point of that container without any loss. That is the law of Pascal's law. See, let us consider a vessel. This is a vessel which is containing the water inside in it, which is enclosed, means it is fully closed system. So, and it has the four openings, that is A, B, C, D. These are the 4 openings it has, and these A, B, C, D are the 4 frictionless pistons. These are the 4 pistons placed at the each opening of that system or a container. And this piston A is having the cross sectional area A1, B is having the cross sectional area A2, and C is having the A3, and D is having the A4 as a cross sectional areas. So we have applied certain force F1 to the piston A. We have applied certain force in the downward direction to the piston A. Then what happens? Then when the force is applied in a inward direction of that container, then because of this inward force, these B, C, D pistons will start to move outward direction because of the inward direction, we have applied some force on this piston A, and because of that force the piston will start to move in a inward direction, that is it will start to move inside this container. So because of this force, this B, C, D pistons will start to move outward direction. So this shows that the external pressure is transmitted in all the directions. Whatever the external pressure F1 we have applied, that is transmitted through the all the directions. So if F1 amount of force is applied on the piston A, then the pressure applied on the piston A will be F1 divided by A1. We know that force divided by cross sectional area gives the pressure. We have the force as F1 and we have cross sectional area as A1. So the force, the pressure on the piston A, that is known as F1 divided by A1. So when we apply certain this pressure on this piston A, all the other pistons will start to move outward direction. To prevent this motion of the other pistons, we have additionally applied forces to the B, C, D pistons, that is F2 amount of force to the piston B, F3 amount of force to the piston C, and F4 amount of force to the piston D, that is in the inward direction. Then we have applied this because to make it prevent the motion of these outward motions of these pistons. So whatever the forces we have applied, that will be same as that of the force F1. So we can write it as F1 divided by A1, that is the pressure 1 is equal to the F2 divided by A2, that is at the point B, that is equal to F3 divided by A3, that is force divided by area at the point C, and F4 that is equal to F4 divided by A4, that is at the point D. So we can write it as P1 is equal to P2 is equal to P3 is equal to P4, that is the pressure applied at a point at a piston A is equal to the pressure applied at a piston B, that is equal to the pressure applied at a piston 3, and that is equal to the pressure applied at a piston 4, that is P1 is equal to P2 is equal to P3 is equal to P4. So by this we can say it as each piston is acted upon by the same pressure as that of the applied pressure on the piston A. We have applied the same pressures on the four same openings. Each of the openings we have applied the same pressures. So hence we can say the change in the pressure is transmitted undiminished in the all the direction. Whatever the change in the pressure, whatever the we have applied certain pressures on one end of the container, that is transmitted at each of the points of that container without any loss. This is the